Welcome and thank you for joining us today for this webcast with the subject Smart Self-Service Infrastructure for the VMware Admin. Now, many organizations have a cloud strategy, maybe even a cloud-first strategy, which means all workloads move to the public cloud. However, organizations quickly came to realize that not every workload can simply move to the cloud and therefore remains on-prem. For those remainer or even returner workloads, enterprises are challenged with delivering a phenomenal infrastructure experience for their clients and be most efficient about it. It's time to look at the cloud as an operating model instead of purely a destination. My name is Tobias Flitsch, Head of Product at Nebulon, where it is our mission to bring the benefits of the public cloud to on-premises infrastructure, from core to edge for any application, bare metal, containerized, or virtualized. Today I'm joined by Michael Lin from Hewlett-Packard Enterprise, and we're presenting how the combination of VMware, the HPE ProLiant server, with Nebulon Smart Infrastructure can enable self-service infrastructure for virtualization. We have a healthy mix of slides and pre-recorded demos prepared for you. Now let me hand it over to Michael for a brief overview of the HPE ProLiant server as a secure and reliable platform for VMware. Michael, take it away.
Thanks, Tobias, for the introduction. Just wanted to say hello to everyone, and I hope that you all are doing well and staying safe. Since we are at a VMware user group forum, I thought we'd kick off by talking a little bit about the long-standing relationship HPE has with VMware. For 19 years, we have been providing innovations, experiences, and expertise to our partners and customers. Together, we have sold thousands of VMware licenses and hold the largest share of the virtualized compute market. HPE has been recognized as the #1 partner for VMware and is the largest VMware authorized training center with thousands of solutions experts who are ready to provide help with anything you need, whether that be sizing an environment properly, figuring out which licenses to use, or picking out proper platforms that fits your needs. That being said, let's dive into the platform that Nebulon leverages in their solution, which is the 2P2U DL380 Gen 10 server, a very popular platform and is a go-to model within our ProLiant portfolio for a variety of workloads, whether that be big data, storage, data warehousing, or virtualization. Leveraging the ProLiant DL380, you are able to consolidate your server footprint by running multiple workloads on a single DL380 due to its forward-looking design, industry-leading performance, and a level of security. The system can support up to 24 small form factor drives or 12 large form factor drives. It comes with a 4x1 gig LOM and an additional flex LOM slot for your choice of networking cards. The HPE Gen 10 systems support the Intel Cascade Lake and Cascade Lake refresh processors, and with our recent release of the Gen 10 Plus platforms, we are able to support the Intel Ice Lake and AMD Milan processors to meet any of your workload performance needs. The platform also provides UEFI BIOS and HPE secure encryption capabilities, but we take security a step further with our Silicon Root of Trust. Our Silicon Root of Trust protects against firmware attacks, detects compromised firmware and malware, and helps recover servers. Now, the term root of trust has become more and more prevalent when other companies talk about their security, but it is important to remember that not all root of trust implementations are equal. The depth and completeness of protections are tied to where the root of trust is anchored, as well as the integrity of the supply chain. HPE has been designing our own ASIC chips for over 10 years, and the Silicon Root of Trust is built on that research and development. Starting at our factory level, custom silicon is effectively welding all the firmware together in our platforms to create something that can be thought of as a digital fingerprint. This digital fingerprint is anchored into the silicon and cannot be changed. So whenever your HPE system boots up, this fingerprint is analyzed, and if anything has been changed in the critical firmware, alarms start ringing. This means that if anything is compromised, you will know about it immediately. Our Silicon Root of Trust goes one step further and not only checks the firmware state at boot up, but continuously checks the validity and integrity of the firmware. And if there is any kind of violation, the user is notified. The impacted area is isolated, and we recover the firmware to its last known good state. You don't have to take our word for it. HPE Silicon Root of Trust was recognized by the Cyber Catalyst program. The Cyber Catalyst program brings together 8 leading insurers to identify cybersecurity solutions that they view as effective in reducing cyber risk. HPE Silicon Root of Trust, along with the Aruba Policy Enforcement Firewall, have been recognized as one of the Cyber Catalyst designated solutions that provides innovative ways in addressing cyber risk, beating out over 150 other products and services that were submitted for evaluation. Because of this designation, HPE Gen 10 server customers qualify for enhanced terms and conditions on individually negotiated cyber insurance policies from participating insurers. Ultimately, the DL380 Gen 10 platform that Nebulon chose to standardize on is not only one of the most secure standardized servers in the world, but also comes with the added HPE values, such as efficient and easy server management tools like the HPE Service Pack for ProLiant, HPE scripting tools, and HPE Intelligent Provisioning. We also bring to the table enhanced levels of compute with next-gen industry standard CPUs, whether that be the Intel Cascade Lake processors on our Gen 10 systems, or the Intel Ice Lake and AMD Milan processors on our Gen 10 Plus systems. This is all offered not only on the DL380 Gen 10 platforms, but our entire broad portfolio, our ProLiant rack servers, tower servers, Apollo systems, bladed systems, edge systems, and more. With that, I want to thank you for the time, and I will now pass the speaking baton back to Tobias to discuss more about Nebulon solutions and features. Thank you for the time.
Thank you, Michael. Now, given the strengths of the HPE ProLiant platform and the experience of HPE in the virtualization space, we have partnered to solve key challenges of enterprises and hosting providers with their application workloads that must remain on-prem in core data centers or at the enterprise edge. Now, reasons to keep them on-prem include lower latency, regulatory requirements, or just simply cost. At the core of their challenges, though, with these workloads is the supporting IT infrastructure. Now, it's because existing on-prem solutions were not really designed to deliver the public cloud experience on premises. Enterprises are challenged with slow application deployments due to the lack of highly skilled resources in every team. Now, these are required to run compute, storage, and network services end-to-end and to support new application deployments. They're also challenged with high infrastructure management overhead, where the IT organization has to manage on a per device level, lacks end-to-end insights, and is mostly occupied with mundane tasks such as firmware and software updating. And they only have restrictive alternatives to expensive 3-tier architectures that can be very complex to manage and they're slow to deploy. And this ties back to requiring highly skilled resources. Now, existing hyperconverged infrastructure software alternatives limit workload density and they lack support for native workloads outside of just virtualization. So sometimes they have to work with the complexity and the cost that is associated with the 3-tier architectures. Now with Nebulon, IT organizations are enabled to deploy and manage and maintain on-premises enterprise application data at scale as simply and as rapidly as in the public cloud. Now, if you are familiar with Cisco Meraki as an example, you know the model. Otherwise, the way to think about how Nebulon does this is by using the lessons from smart home consumer tech and applying it to enterprise IT, specifically in 3 relevant areas: the model, the benefits, and then the use cases. Now, looking at the model first, in a smart solution in the consumer space, take Nest as an example, the control plane is moved to the cloud and it connects to IoT endpoints in a physical device, your thermostat, for example. And now suddenly you gain immediate incremental benefits that are normally just exclusive to the cloud. You get incredible time to value as it is easy to deploy. because it just plugs right into your existing HVAC system or simply connects to your home Wi-Fi. It is simple to automate for a variety of applications. In your home, you can adjust temperature based on weather, you can control security cameras, lights, and other devices, and build entire routines on your own, and when you need it. And you don't have to have a technical degree to do this. It's pretty much self-service infrastructure for your home. You also gain the ability to centrally control all of your devices from anywhere. Your software is kept up to date behind the scenes, and you gain the ability to leverage the intelligence of the cloud that monitors your preferences and then constantly adjusts to better fit your needs. And the third parallel or lesson are the use cases. Taking Nest as an example one more time, it supports any application as a thermostat for security cameras, for smoke detectors as an example, anywhere, so in your home, office, or vacation home, and it adds better control to those use cases. Now, wouldn't it be great if you had the same capabilities for your enterprise on-prem IT infrastructure, for your virtualized applications both at the data center core and in the enterprise edge? Now, with Nebulon Smart Infrastructure, we bring the public cloud experience on-prem through server-embedded infrastructure software that is delivered to customers as a service. You get self-service application infrastructure provisioning for virtualization, but also for containers and bare metal applications, so product teams and application owners can rapidly provision and scale their own infrastructure. You get infrastructure management as a service that ensures that your on-prem infrastructure works reliably and most effectively by using cloud analytics and recommendations along with behind-the-scenes software updates that keeps your infrastructure fleet free from vulnerabilities caused by software or firmware issues. Plus, with a server embedded data plane that runs entirely on a PCIe card in the server, you no longer have to rely on complex and expensive external arrays for your shared and your local block storage needs, and you can simply use the server's SSD capacity without the density and workload restrictions of hyperconverged infrastructure software. Now, this is achieved by Nebulon's architecture that consists of two key components: a cloud-based control plane that ensures operational simplicity, and a PCIe card embedded in your application server that serves the data plane for your enterprise application workloads. Now, with this smart infrastructure solution and its architectural approach to on-prem infrastructure, you get a single top-down solution that addresses key challenges for the core data center and also the enterprise edge. Now, since the reference architectures for Smart Core and Smart Edge under the Smart Infrastructure umbrella use the same technology, customers no longer have to decide for different infrastructure approaches for different deployment models. It's one smart infrastructure solution that works top-down across core and edge for virtualization, but also for containers and bare metal applications. Now, let's have a closer look. So as we have established, Nebulon Smart Infrastructure is server-embedded infrastructure software that is delivered to customers as a service through our cloud, and it makes use of an IoT endpoint that is embedded in the server by the server vendor. And that IoT endpoint provides a data plane, and it establishes a secure management connection with the cloud. Now, this separation of the control plane and the data plane was a conscious decision that we made early on in the development of the solution, and it is at the core of the smart infrastructure benefits. Now, we've taken the management stack that would traditionally live within the on-premises infrastructure and moved it into the cloud, where Nebulon ensures that it's always up to date. It delivers new capabilities on demand, and customers don't have to maintain any of it, right? Think of this as your Gmail account or your Gmail application that is just there, and you get new capabilities all the time. This is also where we do anonymous analytics, where you as an individual customer can benefit from the collective insights and the experience of smart infrastructure customers, including proactive issue notifications and also predictive issue prevention. More about that a little bit later. So what remains on-prem is the lightweight data plane. And that is embedded in a PCI card in your on-prem server. We call that a services processing unit or SPU. Now, updates to this data plane are quick and can be rolled out in a fleet of devices with literally a single button click. So the management and control of your infrastructure sits in the cloud and is maintained by Nebulon, while your private data remains on-prem in your control using this data plane that provides secure, shared, and local enterprise block storage services for your applications, for your servers. Now, this architectural design allows bringing the public cloud experience on-prem, and the benefits that customers gain from cloud management are quite impactful. So let's first talk about self-service infrastructure provisioning. A key challenge for IT organizations with their on-prem infrastructure is being able to quickly respond to new product initiatives and to deliver the necessary IT services to support these product teams and to support the application owners. Now, with traditional approaches, on-prem infrastructure provision is quite slow. The reasons for it are often organizational barriers, but mostly because traditional on-prem infrastructure is not built to deliver a cloud experience. Now, with a cloud experience, the problem is solved by putting the application owner into the driver's seat, by allowing them to provision their own infrastructure. With Nebulon, this is done by means of a service catalog. This service catalog defines what operating system to deploy or what hypervisor, what application, and the right data storage services for that particular application. Now, having a service catalog makes infrastructure provisioning quick, reliable, and repeatable. What that means is that IT organizations can build a catalog of services that meet their company guidelines, and then application owners can provision services and scale these services rapidly at the core or the enterprise edge, wherever they're necessary. And they can do so consistently without ever having to involve the IT team. Now, in this environment here, I have a couple of HPE servers. So what I've done in our lab is I have racked the servers, I have attached them to the network, and I've powered them on. Now, they were automatically connecting to the cloud, leveraging DHCP on the management network, and they automatically registered with the cloud. I've then claimed these servers within my organization here. Now, let's assume that I need a new VMware cluster. Right now, there are no clusters or endpods provisioned. And just for the sake of completion, an application cluster is in what we call an endpod in the Nebulon terminology. Now, all I have to do is create a new endpod up here. And during the process, I select the number of servers. And in this case, I select my HPE ProLiant DL380 Gen 10 servers. And then I select a service template from the service catalog that is provided to me by the IT organization. And then I specify some network configuration options. In this case, I'm going to use DHCP for the network connectivity. And then lastly, I have to provide some basic information for the endpod, like a name, and I have to assign it to my team, right? Now, once I request this new endpod, the Nebulon Cloud will first validate my choices, and then check if there will be any issues with the deployment. Now, this takes a couple of seconds to complete until all of the checks are done. And once this is successful, I can just confirm the creation of the new endpod. And this really kicks off a background operation that provisions all of the data services as defined in the template. Now, in this case, it's data volumes and data protection settings. So in this scenario, it's assumed that there is a separate boot device in the server that provides the VMware operating system. Now, some customers prefer purchasing their servers with the operating system already deployed by their server vendor during manufacturing. And this particular template really facilitates that. Now, after a couple of seconds, the endpod is built, and we can see the new endpod in the Nebulon on web user interface with a snapshot schedule, with the selected servers and their properties. And we can see that there are a bunch of volumes provisioned to all servers in the clusters as defined by my template. And there was no SAN zoning, there was no multipathing configuration or other infrastructure setup required other than what I've mentioned earlier. Now, if we look at this cluster within vCenter, you can see that all of the storage artifacts are set up, and I can start consuming them for VMFS data stores and for my VM storage. Now, back in the Nebulon on UI, I can also turn on the Nebulon VMware integration that will enable cross-stack analytics that provides additional insights into this environment, and that makes troubleshooting a lot easier. And I can also use the same workflow that I've just used for VMware for pods that host Kubernetes or bare metal applications as well. But in any case, I don't have to involve another team. I can self-service provision my own infrastructure when I need it. Next, let's have a look at remote management. So once infrastructure is provisioned, it's all about keeping it running, keeping it up, and optimizing for changing needs. Now, workloads usually don't stay the same, right? They evolve with the project. And with Nebulon's cloud analytics, we can monitor and predict changes and give valuable insights into your infrastructure that is relevant for configuration changes, for sizing or other planning activities. And the same insights can be used by the cloud control plane as part of command execution. Now, since every command passes through the cloud, it can intercept actions that are possibly harmful or misguided. Another major challenge for IT organizations managing large infrastructure environments is keeping firmware and software current. Now, a major pain point is really navigating through compatibility lists and identifying the right mix of versions and then rolling them out across many devices. Now, let's have a closer look at firmware and software management within Nebulon Smart Infrastructure, specifically updates. Now, as I just mentioned, traditionally this is a time-consuming task that requires careful planning and has to be done device by device. However, updates become quite simple if the majority of your software actually runs in the cloud and is provided to you as a service. You only have to update the bare minimum in your infrastructure centrally and non-disruptively. Now, with Nebulon, the cloud control plane with its user interface are constantly and automatically updated behind the scenes, so you don't have to worry about it. And if I click and refresh my UI here a couple of times, eventually I'll get a new feature in the user interface after a browser refresh here. Now, when it comes to the data plane, right, you are in control over when the update happens. And I can show you how easy it is to perform, for example, through the user interface. Now here you have a list of application clusters or endpods. And as you can see, they're currently all running version 1.1.1. Right? Now the Nebulon Cloud has all the knowledge about the software mix and knows that these pods actually should be running a different version. So it recommends an update to version 1.1.2. I can now select all of the endpods that I want to update and start the process. They are now all updated in the background, and I can follow the progress through the Nebulon user interface under activities. Now, internally, the update process ensures that there's no disruption to application workloads by means of a rolling update. So each server within an application cluster is updated one at a time, and the built-in redundancy ensures that data is served at all times. However, different application clusters, different endpods across a distributed environment are updated in parallel. And I don't have to log into each of these clusters individually or their management interface individually. I can initiate this update centrally from the cloud, and I can also monitor the progress of the update centrally as well. Now, this is especially handy in edge use cases where you have infrastructure scattered across the country or the globe. Now, once done, you can see that they're now all running the suggested version, and therefore the Nebulon Cloud does not recommend any further updates. So your operational overhead is heavily reduced if you have the necessary insight into your infrastructure, if you have fleet management capabilities, and if you have to no longer deal with the complexities of traditional firmware and software updates. Now, let's have a look at automation. Now, every large organization has invested in some form of automation of their infrastructure. Some are quite advanced with complicated workflows and integrated most of their environment, and others are still adjusting to this new paradigm. In any case, it is done for the same reasons, and that is eliminating repetitive tasks and doing more with fewer resources. Now, it turns out that this is not very easy to do with on-prem infrastructure. It is easy to do, or easier to do, with the public cloud because there's just one API and it's consistent across all services, right? On-prem, every device has their own API endpoint, its own version, and potentially functional level, right? And all of that has to be considered when writing scripts or when you design automation workflows. Now, with the Nebulon Cloud Control Plane, it's one API with one version that works and scales for the entire enterprise. That makes reporting, that makes automation so much easier and helps organizations achieve infrastructure as code and to do more with less. Now here I have an example where I can use Python to automate the same process that I went through in the user interface. Now to simplify getting started with our GraphQL API, we provide customers with a set of software development kits or SDKs. And here I'm using the Python SDK, which you can easily install using pip. The other thing that I'm using here is Jupyter, so that I can just walk you through all of the steps and really what's going on. Now, the first step in the script is to import the Nebulon module. Then I log into the Nebulon Cloud with my user credentials. In this case, I'm loading them from environment variables. Then I select the 4 HPE servers. In this case, I'm selecting them by using their serial numbers. However, the API provides you with options to select them via a wide range of properties of servers, right? Next, I use the SDK to programmatically update all SPUs. So all of the SPUs in the servers, and I update them to a specific software version that I want to use in this environment. So I can actually use code to update my infrastructure and not just the user interface, right? Now, this is extremely useful if you have a working paradigm where you have tested and approved a specific version and you only want to use that particular version. And this way you can include this update or downgrade step for example, in your Terraform or Ansible playbooks as part of your automation routines. Now, of course, software updates are not instantaneous, but they take a few minutes to complete. This also depends on the specific software package and its payload and my network bandwidth, right? In any case, you can see that these SPUs are updating in parallel, and the updates complete in just a few minutes, and in 124 in this case. Next up, we select my nPod group, right? The team or use case that owns this new nPod. I select the template to use again. I'm using the vSphere template as I did before. And I provide the network configuration information for this nPod. And then finally, I create the nPod, which runs through the same validation steps as the user interface does. But when doing that programmatically, right, it would not show a user interface message. But instead, if there would be any validation errors or warnings, etc., an exception would be thrown. But for this demo, I already know that this validation will work. So the Python code therefore does not include any error handling logic really. Now the nPod is created and we can see the same configuration as we've seen before. So we have 4 servers in this nPod, and we have a couple of volumes provisioned, and here we can see that the software version is indeed version 1.1.2, as done earlier in the automation workflow. Of course, we can also clean up and delete the nPod via code. Now, this is programmatic management of Nebulon smart infrastructure. However, we know that most VMware users don't really use Python for automation for various reasons, but instead rely on PowerCLI. Now, as I mentioned earlier, Nebulon provides a couple of SDKs for interacting with the API. And specifically for VMware users and also Windows users, I guess, we have a PowerShell module, and that is easily downloaded from the PowerShell gallery. Now, let me show you an example of that that is a bit different from what I've shown you so far. In this case, the servers do not have a boot device configured. You can see that they're all in a boot loop here because they can't find a boot device. On the left, you can see a vCenter instance that is empty, apart from a data center that I've already defined. And then on the bottom right, you can see that I have a PowerShell session loaded up on my Mac with PowerCLI installed and the PowerShell module from Nebulon installed. Now I've prepared a script that will end-to-end provision a VMware cluster. So if I execute the script, it will ask me for my vCenter credentials, the one on the left, and then run through a sequence that is quite similar to the ones before, where it will select for HPE ProLiant DL380 Gen 10 servers, but this time it's using a vSphere 7 template that provisions a boot volume. And you can see that with the boot volume property being set to true. And similar as before, the script was passing some information to the nPod creation process. It's pretty much the same data as in the Python script, but in this case, it's just hidden within the script, hard-coded in the PowerShell script, and I'm not printing it to the console here. Now, the provisioning of the nPod in this case takes a bit longer than before, and the reason is that in this case, the creation process will also provision a boot volume, right? A boot volume for all 4 of those servers. Which is basically defined in the application template that was provided to me by the IT organization. Now, once all of these volumes are provisioned, the servers are kicked and they enter a reboot process. But this time they will find a new boot device, right? Because we've just provisioned one through the nPod creation. And this boot device is running VMware 7, and that's what they're now using to boot from. So now, since this is VMUG, right, we're obviously using VMware, but as a side note, right, this would work similarly with a non-VMware image, right? If you have Windows or Linux, where you could, for example, use a cloud-init image that automatically configures your operating system to your specific needs, right? That would work exactly the same. In this particular case, it just happens to be VMware, right? Now, once the servers are rebooted and completely booted into ESXi, the script can form the cluster where it does a couple of things, right? It creates the standard network switches and configures the credentials of the server, and it does that for all of the 4 servers that I've selected earlier in the script, and then it basically adds these servers into the cluster in vCenter, and you can see that popping up here on the top left. You can see the VMUG May 21 cluster getting populated with servers. It then adds the VMFS data stores to all of the Nebulon provisioned volumes. So if you look at the cluster now, it now has 4 servers in there, and if we navigate to the data stores, you can see that they're all set up with VMFS file systems. Now I spare you the details of showing this cluster in Nebulon on, as we've seen that a couple of times now. It looks pretty much the same. So what I've shown you here is self-service infrastructure provisioning. I've shown you remote fleet management by the example of software updates, and I've showed you automation using Python and PowerShell. Now, you can see that these are properties of the public cloud experience, but I've demonstrated them for on-premises infrastructure. And what is required in addition to just the cloud control plane is a data plane that can securely enable this cloud management. So really the other ingredient to bringing the public cloud experience to on-prem infrastructure is a data plane that supports any application, anywhere, with better control. Now, there are many reasons why certain applications and data is kept on-prem and is not moving to the cloud. There are also many reasons why a particular application is using virtualization, why it is using Kubernetes or containers, or why it is using bare metal as an infrastructure. Think about an in-memory database that wants to use 100% of the resources of the server. Right? So limiting your infrastructure to support just one of the workloads will come with challenges, specifically since it restricts developers and the product teams in terms of design and architecture. An application that is built for virtualization is built quite differently than a cloud-native application running on Kubernetes, and application development is a constant evolution. So in order to quickly react to changing needs, infrastructure that is hypervisor agnostic and operating system independent is required. And that really gives you the freedom of easily shifting services and really support your application teams. Along the same lines, you want a cost-effective infrastructure that delivers the same data services in different deployment scenarios, in the core, edge, or if it is a hosted service, where the size is the only factor that really changes. An application that was developed for the core can then be easily rolled out at the edge, just at a smaller scale, but it still receives enterprise data services. Now, this is done by having a little enterprise storage array embedded into the server, not on the CPU, because this is required to run the applications, but this IoT endpoint in the server, the services processing unit or SPU. That gives you higher density, as you don't have an external storage array, and you don't have to compensate for the CPU, memory, and networking overhead of software-defined storage as you get it from hyperconverged infrastructure software. Now, lastly, and also quite importantly, full control over the boot device and separation of data from the operating system is needed. This is really what enables customers to quickly alter the personality of servers, and from one application cluster to another. This is really what enables customers to deploy application clusters with the operating system, with the application, with the data volumes in just a couple of minutes, as I've shown you earlier. This is really what enables customers to remotely update and maintain clusters without service disruption, because the data plane is unimpacted when the operating system reboots, fails, or undergoes maintenance. So why Nebulon Smart Infrastructure? Now, application owners and product teams are put into the driver's seat, and they can self-service provision their infrastructure from rack to the full application stack on their own, accelerating time to value. There are massive gains when it comes to operational overhead through zero-touch remote fleet management, AI cloud assistance, and API-first infrastructure management that is delivered as a service. You get cloud-like operations for your on-prem infrastructure. By avoiding the expense of external storage arrays and avoiding the restrictions of hyperconverged infrastructure software, you gain significant efficiency and cost improvements. And lastly, with a solution that is operating system and application independent, you protect your investment for today and in the future. Now, if you can get all of these benefits for your application workloads in your on-prem infrastructure, you no longer have to force applications into the cloud to gain those benefits that are better served on-prem. You can now start thinking about the cloud as an operating model instead of purely a destination. Now, today, I have just briefly provided an overview of Nebulon Smart Infrastructure and how it can be used in a virtualized environment. We do have a lot more detail to share, so please check out our resources on our website, nebulon.com, and schedule some time with our SAs that can walk you through all of the steps that I've shown you today briefly in more detail. The automation examples I showed, and we can also facilitate remote proof of concepts where you can try all of this out on your own. In any case, thank you all for attending and listening. And Michael, thank you for your support. And I think we do have some time for questions now.